there.
There's two types of these guys. There's the linear, and then there's the non-linear. If you notice, every one of these are raised to the first power. X to the first, negative x to the first, x to the first plus 1, x to the first plus 2. These are linear. Linear, you're going to deal with A and B. So this is the way you do it. You're going to say negative x over x plus 1 times x plus 2 is equal to A over x plus 1 plus B over x plus 2. And if there was a third term, you would, like x plus 3, you would say plus C over x plus 3. Now, you're going to solve this by multiplying the whole thing by the common denominator. So I'm going to take my handy dandy. This is the same method every single time, except on the quadratic or the non-linear. So I'm going to multiply by x plus 1 times x plus 2 over 1. Now, what is that going to do to this side? It's going to cancel this to this. So, on the left side, you're always going to get the numerator of this fraction. That's what you're supposed to get. And then over here, you're going to get A times x plus 2 plus B times x plus 1. Okay, now there's two ways to solve these type of equations. One way is called equivalent coefficients. I'm just going to put them. I'm just going to put equal coefficients. The other way, actually, we'll make that number 2. Number 1 is 0 factors. That's the easiest way. Now, sometimes you're not able to do it because of the type of problem that you're doing. So in this case, what will give you a 0 here? Negative 2. What will give you a 0 here? So we're going to plug in, so we're not going to use the equal coefficients. We're going to use this, and we're going to pick two numbers, negative 2 and negative 1. We're going to plug in negative 2 first. So negative 2, so that's negative parentheses. So that's a negative 2 in there, equals A times negative 2 plus 2 plus B times negative 2 plus 1. Now what happens to the A factor, or the A term? It goes away, and that's what will happen. And that leaves you with 2 is equal to negative 2 plus 1 is what? Negative 1B. So B is equal to what? Okay, so write that down. So now you know that B is equal to negative 2. Any questions? Now that's just a coincidence that it came out to be the same. That's just a coincidence. Okay? So now that you found B, go back and find A by plugging in what? Negative 1. So I'm going to cross that out, and I've got B is equal to negative 2. And now I'm going to erase all this and start again. Now I'm going to plug in negative 1. Negative parentheses, negative 1, equals A times negative 1 plus 2 plus b times -1 plus 1. And of course, the b term goes out. And we get 1 is equal to a times -1 plus 2 is 1. So a is equal to 1. Put over here, a is equal to 1. So now, instead of dealing with this, you have to deal with 1 over x plus 1 minus, really, minus 2 over x plus 2. And the reason you would want to do this in calculus is because in calculus, I'm just showing you this, you don't have to know it, but I'm showing you why. When you get to calculus, you'll be taking the antiderivative of this, and you can't take the antiderivative of this the way it's written. So you have to break it into two antiderivatives. And that's why you have to be able to do, you have to break up this term. Problem solving. You got a problem, whether it's resources, whether it's human resources, whether it's financial, whether it's mechanical. What do you do with a problem when you first get it? You break it up. You break it apart. If you've got a problem, you have to break it up into its factors, no matter if it's, what do you call it, customer service, or whether it's how to take a transmission apart, or whatever the case may be. You have to be able to break it apart some way, somehow, and get it into its factors and find the problem. So again, the manipulation, Calc 1, 2, and 3 is nothing but manipulation and tearing apart single problems and breaking them up and putting them back together. That's what it is. So that's why you learn how to do stuff like this. Okay? So that's the basic type of partial fractions. So that's one of the problems you'll see on the test. Minus the integration marks. All right, let's go to another one. I'm just doing the examples out of the book because there is no other way to do this. There is no other method. Partial fractions is partial fractions. That's what they got. They got the same thing. That means we know what we're doing. All right. Now, what if you got one like this? Let me cut it out. Now, remember, you have to look at the degrees of the problem. Now, what if you got a problem like this? What do you do? Well, as soon as I can find the whiteboard, there we go. You look at the degrees so you can see what to do. What do you notice about the degrees of this one? Well, it's nonlinear because you got the fourth and the third degree, so it's different. But what can you also do when the degree of the denominator is smaller than the degree of the numerator? Nope. Long what? Long division. Now, the reason they put this one in here is because you're going to see some that has equivalent or greater than numerator. The degree is greater than. You've got to watch it because sometimes you can use long division. And that's what you do, is use long division. Again, you're finding a way to manipulate the problem. Take it apart. So what do you have to make sure of in long division? I told y'all this 2 or 3 weeks ago.
Space is filled.
Everything's got to be filled. So x to the third plus 0x squared minus 4x to the first plus 0x to the 0. I don't think we do need it. Plus 0x to the 0. Divided into 2x to the fourth minus 8x, no, got to put in a cube, plus 0x cubed minus 8x squared plus 5x minus 2. So, how many times will x to the third, remember your exponents, go into 2x to the fourth? 2x times. What's 2x times x to the third?
2x to the fourth.
There you go. 2 times 0 is 0x to the third. 2 times negative 4 is negative 8 squared. And 2 times 0 is 0x to the first. What do we always do in division at this point? You always subtract. So that's going to turn this into a negative, this into a negative, this into a positive, and this into a negative. First column always supposed to what? Cancel out. 0x cubed negative 8x squared plus 8x squared is 0x squared. 5x minus 0x is 5x. And the 2 comes down to help out. And at this point, you're done. Why? Because x cubed cannot go into you can't go any further. Because the only thing you could do is you put a 0 in, that's going to zero everything out. So you're done. So this is the remainder. So it's going to be 2x plus 5x minus 2 over x cubed minus 4x. And that should be your answer. I don't know if this book wants you to carry it further. It shouldn't. Huh?
They want us to do the whole thing.
So they stopped here?
Yeah.
They want you to keep going with x cubed?
They want you to go away and get all the numbers.
Okay. Let me see if they're using equal coefficients, ax plus b. Let me see what they're doing. Yep.
Oh, boo.
Yeah, I know. Since it's x cubed, they're doing since it breaks up into x to the first, x to the first, x to the first. So, sorry guys, they want you to go all the way through. Okay. We'll do that. It's a little premature, I thought. So, we got the 2x. So, let's rewrite this, and we're going to factor this. So, I'm just going to focus on this. So, 5x minus 2 over x, and that's going to leave me with x squared minus 4, which is x plus 2. Which shortcut is that? X minus 2. Shortcut number 3, Hubert. That's right, class. Thanks for interacting. So that's going to be a over x plus b over x plus 2 plus c over x minus 2. right, multiply through by the common denominator and get to work. I'm going to let y'all do this one. If you can't do it, just chalk it up as failure. So the common denominator is x times x plus 2 times x minus 2, correct?
Yes.
And of course that's going to cancel there. And you're going to be left with 5x minus 2 is equal to a times x plus 2 times x minus 2 plus b times x minus 2 plus c times x plus 2. Now you got to do a lot of algebra. And as my Calc 1 students and Calc 2 students find out, what's 80% of calculus? Algebra. So if you suck at algebra, you're going to suck at calculus. Five x minus 2 is equal to a times x squared minus 4 plus bx squared minus 2bx plus cx squared minus 2cx. I'm going to change this to ax squared minus 4. Now we change back. Now we change from an eraser to a highlighter. Well, I didn't even use the highlighter. So that's going to be 5x minus 2 is equal to ax squared minus 4a plus bx squared minus 2bx plus cx squared minus 2cx. The chances are we're not going to be able to use our zero factor. I was going to say we could use the negative up at the, we might, and I don't know if they want us to do this. You could use it right here and say positive 2 and negative 2 and 0. Positive 2, negative 2, and 0. Let me look at it and see. Positive 2 will give you a 0 right here and a 0 right here. But you have a, now you plug in 2 right there. That would work. So we may not have to do this, but we might be able to do equivalent coefficients. 5x minus 2 is equal to get all your ax squareds, all your x squareds together. That's going to be ax squared plus b x squared plus c x squared. And then get your bx's together and your cx's together. Minus 2bx minus 2cx minus 4a. I'll check and make sure I haven't left out anything. And then 5x minus 2 is equal to, factor out what? ABC? A plus B plus C x squared. Factor out a negative 2x right here. I'm thinking, hold on. Yeah, the negative 2x, that's going to leave you with b plus c times negative 2x, right? Yeah. And minus 4a. Now, what you can do, you don't have an x squared term on the left side. And you don't have you have an x term and you have an x to the 0 term. So you can use those two to maybe figure out these, but I don't think it's going to help you. I think you're going to have to use the 0 factor. You could plug in 5x is equal to this. And you could plug in negative 2 is equal to this. You can get A. A is about the only thing you can get. I'm looking to see 5x of 5. Yeah, it's not going to work. But I can get A is equal to 1/2. I think I can get that. So we're going to have to use the 0 factor. I was going to try to use the equivalent coefficients. So plug in positive 2. If you plug in positive 2, that's going to knock this one out, and that's going to knock this one out, and that's going to leave you with what? 4 times 2 is what? 8. Well, we also have over here 2 times, it's 10 minus 2, that's 8 over there. And you're going to get, let me just do one up here and say 8 is equal to C times 2 times 4. So 8 is equal to 8C. So C is equal to 1. Thank you. All right, write that down. C is equal to 1. And now let's do the negative 2. Negative 2 is going to take this one out. And we're going to take this one out. So now we can find B. So negative 2 will give us a negative 12 is equal to negative 12B, I'm sorry, negative 2B times negative 4 is going to be 8B. Somebody help me out. Is that right? Let me check it, make sure. Negative 2 times 5 is negative 10, minus 2 is negative 12. Negative 2 is 4 times negative 2 is 8. That's going to be negative, that's going to be positive 8B, right? Divide by 8. B is equal to negative what? 3/2. Write that down. And now plug in 0. 0 is going to knock this one out and knock this one out. And you're going to get -2 is equal to 0 plus 2, and 0 minus 2 is what? 2 times -2, which is negative what? -4a. Divide by -4. Divide by -4, and a is equal to 1/2. So now you can rewrite this as 1/2. Is that 1/2? 1/2 plus or minus, so that changes to a minus, 3/2 over x plus 2, and 1 over x minus 2. Now you could easily change those by putting this x over 1, so that'd be 1 over 2x minus 3 over 2 times x plus 2 plus 1 over x minus 2, however you want to write it. But that's your answer. So again, you took this, oh, you got to put the 2x with it, sorry. 2x plus this, so that'd be 2x plus all of this. So always try to use the 0 factor. You can use the 0 factor right here when you have these plus and minuses, and this x beside this c, you can make that x is equal to 0 and see what you mean. Now, if you plug in your 0 factors and you don't get a, b, and c, then you have to continue on and you have to find the equivalent fractions, which we're going to do here in just a minute. That's maybe a test question. Probably not. Yeah, that's too much work. Heaven forbid y'all do work.
You covered about all the short ones.
Huh?
That was a short one compared to the.
They got another one in here.
Oh, they get homework gets pretty well.
Well, I'm not going to.
You gave us all of them.
Oh, okay. Well, let's try that one. At least you don't have to use long division.
Still moving.
Yep. So you're still going to use A, B, and C. A, B, C. Give y'all a minute to set it up. I wish I could eat my lunch, but I don't have it for. It's my luck today. Go to the doctor's office and have to wait for an hour. No, get my lunch. I know. No, they took them out. They fixed. Uh, well, I'll go down there, but I don't have it in my office. They're going to make the canteen into the library and make the library downstairs into the canteen, which is smart. I think that's very smart. The thing is, they're going to let you eat in the new library with all the tables in there. Who knows? Now, when you have an exponent, you have to go with the highest exponent. You have to lead up to the highest exponent. So it's going to be x minus 1, x minus 1 squared, and x minus 1 to the third. That's going to be your denominators. You have to build up. Please. Now, as the old saying is, get to it. Which shortcut is that in the front? X minus 1 quantity squared.
3.
2.
2. I did that.
X minus 1 quantity squared, shortcut number 2. X squared minus 2x plus 1. But I don't know if you have to go that way because, well, you're going to have to because we can only find what? Negative. We can only find positive 1, and that's just going to give us C. Can't find A and B. So that means we're going to have to use equivalent fractions. Equivalent coefficients. That better be what they did because there ain't no way to get it. Yep, they plugged in -1, which I told you that would give us, no, they're doing substitution, okay. That's what they're doing. Well, I guess we can do that too. Wonder if we could do leading forth. I mean, let me look at it. It's going to be ax squared minus 2ax plus a plus bx minus b. Let's go ahead and plug in plus 1. And when you plug in plus 1, we get 2 is equal to plus 1 takes that out, plus 1 takes that out, so C is equal to what? That's when X is equal to positive 1. Okay, so I use that to find C. I'm going to go ahead and expand it just to see if we're able to do anything with it. So that's going to be 2x is equal to ax squared minus 8x plus a plus bx minus b plus c. And that's going to give me, if I take these two and put them together, because this is 2x, I'll get 2x is equal to negative a plus b times x. So 2 is equal to negative a plus b. That's one. That's not going to help us very much, so we're going to have to use something else, because I think that's what they got. I don't know if they did or not. That's not going to help us very much. But if we plug in negative 1, the opposite of 1, because it's easy math, we might get something to go with that to use solving systems of equations. So let's see. Plug in negative 1. Plug in negative 1, that's going to give us negative 2. I don't understand how I've not used it. Maybe somebody can help me with that one day. Tell me how I've changed the eraser to a highlighter when I haven't even used the highlighter. It's in Russian. Alright, so that's going to be, when x is equal to negative 1, we're going to get negative 2 is equal to negative 2 squared is 4. That's going to be 4a, right? And then negative 1 be negative 2b minus 1. That minus 1 will come over here, so that'd be negative 1 is equal to 4a minus 2b. And now I've got that and this. Let's see what happens. 2 is equal to negative a plus b. So what am I going to multiply the bottom by? 2. I'm going to multiply by 2 right here. And that's going to give me 4 is equal to negative 2a minus or plus 2b. right? And -1 plus 4 is 3. That goes out. 4a minus 2a is 2a. And a is equal to 3/2. Now you can plug that back in up here. See what it gives us. Or we can plug it in over there. So that's going to give us 3/2. So -2 is equal to 4 times 3/2 minus 2b. And 4, what's 12/2? 6. Minus 6 is going to be -8 is equal to -2b. B is equal to 8. Y'all check me. So now we're going to have A is 3/2. What? Yeah, you're right. So that's going to be A is 3/2. Mr. Carvell, check this. You got to go check it and make sure I got the right. I got the right mistake. 4 over B.
A is 0.
A is 0.
Yeah.
How did I get it?
You only use that for 2 terms.
And we've done something totally wrong.
Because you got an A all by itself right there. You got A minus B plus C is all equal to 0. So that's got to be calculated into it too.
So they did, okay, hold on.
Not that that's the way to go. But
No, evidently this is not one that you do with equivalent. I think with and a lot of times this is trial and error. And you're not going to look at a problem and say, okay, we're going to go this route. You have to play with it. Or you can just look at the book. All right, so we've got, let me just do this. 0x squared plus 2x plus 0x to the 0 power is equal to, and let's factor out the a, and we only got one a x squared, got that, minus a plus b times x, right? And then a minus b plus c, a minus b plus c.
That's an x minus 1 squared, so that's going to be a 2, -2.
Where do you see x minus 1 squared?
You're going to get x
Oh,
squared
right here, 2.
Yeah.
Okay.
That's what's messing everything.
Okay. All right, so that's going to be -2a right here. Okay, now, what they mean by equivalent or equal coefficients is the coefficient for x squared is 0. So therefore, a is equal to what? 0. So from that yellow highlighter, a is equal to 0. Now, the x term, we'll use another color highlighter, is what? 2. And 2 is equal to that. So we'll go down here and we'll say positive 2 is equal to -2a plus what? B. Now B is equal, A is equal to what? So you're going to take that out. So B is equal to 2.
Now you got, because A is 0, and minus B is equal to C.
Yeah. Yeah. See, right here, 0, let's just do the equivalent coefficients so everybody will know what they mean. Take green. And this, since that x is not there, that x is not there either, so let me put an x to the 0 here. Okay, so a minus b plus c is equal to 0, and a and b is 0 minus 2 is equal, plus c is equal to 0. Bring the minus 2 over, c is equal to 2. So a is 0, b is 2, and c is 2. So our answer is this is equal to 2 over x minus 1 squared plus 2 over x minus 1 to the third power. Okay, now I think I've covered A, B, and C. I want to cover a quadratic.
It's an X.
Oh, it is?
It's a mixture of linear and quadratic.
Okay.
And then a pure quadratic would be the last one.
Well, I want to do the last one.
I think it's pure.
Hold on, let me get, what page is it on?
The last one? 492.
492?
Yeah, it's a, well, it's not totally pure either.
Well, they use the ax plus b plus cx plus d, so that's good. All right, so let's write this one down. Save as cube, quadratic. And pull it up. These are the ones I'm used to dealing with. Okay, when you see a quadratic in there, you got something totally different now. You got to build up. So that's going to be x squared plus 1 to the first power times x squared plus 1 to the second power times x minus 1. So you're going to have 3. But the first two are quadratic because that x squared in the parentheses, that's a quadratic. So you're going to have to put ax plus b, cx plus d on top of those because of the quadratic. And that's what they, if you look at example, what examples is 5?
Yeah.
Make sure you put a star beside example 5 because that's where they show you if you have a quadratic. And I'll put a highlighter right there. This guy right here. That means you got to use ax squared plus b. And if you have to use it again, it's cx plus d. So when you start this one up, you're going to get 2x over x squared plus 1 to the second power times x minus 1 is equal to ax plus b over the x squared plus 1 to the first power so that's going to be ax plus b over x squared plus 1 to the first power plus cx plus d over x squared plus 1 to the second power plus, what comes after d? E over x minus 1. Second power, 2. Second power, 2. First power, 1. That's why you were doing A, B, and C before. So, to cancel out, you get 2x is equal to ax plus b times what? X squared plus 1 times what? X minus 1. Plus cx plus d times what? X minus 1. Plus e times x squared plus 1, quantity squared, and x minus 1. Now, you can use positive 1. You can use 0. No, you can't use 0. I only see positive 1. I don't know if that's going to help you. You might have to expand this one. They expanded into the example?
Yeah.
Yep, you're going to have to use your algebra skills. Start with your methods.
I've discovered, it's been a long time since I took about discovery variance, you're always going to have to expand.
Yeah. It's only the A, B's, and C's that you can get to use the zero property.
The trouble I'm having on the homework is I forget all of the mistakes people make and I can't remember. You know?
Yeah.
Like, well, the one you had, when you have to do division, you tend to leave out what you divided out. So you get it wrong. So there's a bunch of little, if you remember them all, you can pass them on. I just keep making them.
Listen, I make them myself. You know the worst thing than the teacher making a mistake? Teacher making a mistake and trying to cover it up that he didn't make a mistake. You ever had one of those?
Yeah, usually don't do it.
Well, let's see. 2x ax plus b times, let's say it's going to be x to the third minus x squared plus x minus 1.
Actually, they didn't expand this.
They didn't?
They did start substituting.
Well, they only can substitute a positive 1.
Oh, yeah.
What did they do after that?
I don't know what they did here.
Okay. Well, they probably used something. Well, then we'll go ahead and use a positive 1.
They did find E.
Well, let's go ahead and plug in a positive 1 like I said. If we plug in a positive 1 here, what happens? Goes out. Positive 1 here. Well, then positive 1 takes out everything.
Yeah.
Okay. Hold on. Can't use negative 1.
Yes.
They didn't expand it first?
No, they did a substitution somehow. It ended up to be 4E.
Well, x minus 1 is the same in all. I don't see how they could have done it without. Where's the next page? There's x is equal to 1.
Reduces to 2 is equal to 4E, so we use 1. That make easy. Oh,
How did they get out? They didn't. They can't use they x minus 1 supposed to be on e.
But they put a minus 1 there and square it, so you got 2. So that's how they substitute. Because all the other ones will.
I'm looking at it. Hold on. How did they get by with not putting x minus 1 right here?
It's a x. It's a
You know who the X minus
Where's mine? I think I got a mistake. Yep, that's it. Nobody called it. Let me go ahead here. Oh yeah, I saw that. I thought it was. There. Okay, now we can plug in 1. I thought that was unusual. 1. 1 will take this term out and take this term out, so it'll leave that one, which will be 2 is equal to e times 2 squared is 4 plus 1 is 5, and 5 squared is 25. And divide by 25. E is equal to 2/25.
Well, you put the 1 in, that's squared, that's 2. 2 squared is 4.
Oh, okay, my bad. I was doing 2 squared.
It's so easy to get lost.
Yeah, it is, because you're thinking of 2, and then you go over there and you put 2 in instead of 1. Okay, 1 squared is 1 plus 2. 2 squared is 4. 4e. There we go. And divide by 4. E is equal to 1/2. Okay, now they're going to have to expand it.
Well, now in here they continue the substitution somehow. Well, yeah, it is expanded.
There's no way. They're going to have to expand
They
it.
expanded now, yeah.
So 2x is equal to ax plus b times x to the third minus x squared plus x minus 1 plus cx squared minus cx plus dx minus d plus e times x squared. Now that'll be x to the 4th. Hold on. Oh, this thing is so sometimes. Okay, it's just figures now. X to the 4th plus 2x squared plus 1. 2x is equal to ax to the fourth minus ax squared plus ax, that'll be ax to the third, plus ax squared minus a plus bx to the third minus bx squared plus bx minus b plus cx squared minus cx plus dx minus d plus ex to the fourth plus 2ex squared plus e. So now all my x to the fourth terms, okay, 0x to the fourth plus 0x to the third plus 0x squared plus 2x plus 0 is equal to a plus e. That's my fourth terms. A plus e x squared. My third terms, I've got that, no more third terms. So plus negative a plus b to the x third plus a minus b plus c plus 2e x squared. Y'all check it. Plus 2e x squared. Now take out squares here, 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 and here. I need to make it smaller. Plus bx, so that's b minus c plus d x. That's going to take out the x there, the x there, the x there, minus or plus a negative a minus b minus d plus e x to the 0. That takes care of that, that, and that. So 0 is equal to a plus e, and e is 1/2, so a is negative 1/2. And the next one, we just did x to the fourth. That's supposed to be x to the fourth, sorry. Okay, so 0 is equal to negative a plus b, and negative a, so 0 is equal to negative 1/2 plus b, so b is equal to negative 1/2. 0, and I just did what? The cube. Okay. Now, x squared is going to be 0. So 0 is equal to a minus b plus c plus 2e. And a and b is negative 1/2. 0 is equal to negative 1/2 plus negative 1/2 plus c plus 2 times 1/2 is 1. So negative 1/2 plus negative 1/2, that's negative 1. So c is equal to 0. Y'all check my math.
Well, it looks like on their unanswered, it's -1.
Okay, we'll check to see what I got there. It looks like to me, negative 1/2 plus negative 1/2 is negative what? That's negative 1, right?
Yes, -1.
Negative 1, you take it over, that would be positive 1. And then you bring that positive 1 over, so I got a sign messed up somewhere. You got to find that sign.
A is -1/2. B
There it is.
is -1.
Right here. Negative, there it is. So that's going to give us a negative negative, which would be a positive. Z1, it should be 1. Negative 1. What did it come out to be?
-1.
Okay.
See, all this work you're doing now,
Yep.
they left out.
Oh yeah, that's
As a matter of fact, it's the shortest work problem in here because they just say,
yeah, y'all know what you're doing. And now plug in your numbers here. So that's going to be negative 1/2 minus negative 1/2 plus 1/2. That thing is in the way. Is equal to what? Oh, I didn't do x. I'm sorry, I didn't do x. So let me do x. Sorry, I'm running out of room. So b, or 2, is equal to, b is negative 1/2, c is negative 1, and d is what we're finding. So that's going to be negative 2/2, so that's negative 3/2. Bring 3/2 over, that's 2 plus 3/2 is going to be 5/2. Checking in and make sure the 5/2 is D.
D is 1.
Okay, I got a sign. Let me check my signs. D,
We're on D, so we're just on H.
so there's positive, negative C, positive D, X. So that's negative 1/2, positive 1, positive 1. Let's see if that works. Negative 1/2 plus 1 plus D, right?
Plus D is equal to 2.
Is equal to 2. So I messed up that right there. Plus 1. So that's plus 2/2. So negative 1/2 plus 2/2 is 1/2. 1/2 subtracted.
But still
Something wrong. What did D come out to be?
comes out to be a constant 1.
Trying to figure out how they got that. Means they're subtracting 1. How are they subtracting 1 when all we can get is 2/2? or 1/2. Okay, somebody suggest something.
Quit.
Yeah. Must be leaving something out. There must be something. Do they have B minus C plus D?
Yeah, that's,
They don't have it?
B minus B plus C.
B minus D?
B, no. See, I can't tell because that's where they left off back up in the beginning.
B minus C plus D. I'm looking to see if I got the signs wrong.
But you're on X. X is, they have minus an A. They got a minus A in here too.
I've got a minus A here.
Yeah, they got it in the X.
They have a minus A?
Yeah. That's E.
I'm looking. You said they had a minus AX.
Yeah. Oh,
I'm looking.
you got X to the fourth, X to the third, X to the second. So there must be an X in here.
Right here.
Yeah.
Well, that's still.
Still not.
Well, that's the minus A to the X.
With an A is the 1/2.
Was that X to the second?
No, that's an A, so that's a X to the first.
Oh, it's supposed to be, well, negative. Oh, I see what you're saying now. Okay. I wish this thing quit doing what it's doing.
You made it about 5 minutes later.
Well, I'm sorry.
I don't care.
I know some of y'all are gonna have a panic
no.
attack.
Keep going.
I'm trying to finish it.
So
2 is equal to a negative 1/2 would be 1/2 plus 1/2. There we go. Is equal or plus D, and D is equal to 1. Now that should be what they got.
And that doesn't.
And then you can take the rest and plug it in to get the rest. Plus D, just for everybody to know.
What's D?
Yeah.
The number is positive 1.
Yeah. So put D is equal to 1 down here so y'all can check your work. I'll try not to give one like that on the test.
And E, you already got. It's 1/2. You got it at the beginning.
Okay, listen. The homework is up. The test is up. Y'all don't need to come back unless you got questions. I'll be in my office at this time. So if you have questions Thursday, let me know.
Oh, we will. I got something.
Okay.
You said you're not gonna put one like this on there?
Yeah,
Or you are?
I'm not, just yours.
It would take a half an hour to do one of these.
I hear you.
Take a look on page 494,
Hold on a minute, I gotta stop the,
and I'll show you the problems you get. And of course, I say a half an hour, that's somebody's an expert. So it takes me an hour to get through and get it wrong.